Okay, this is my favorite part of solving equations. It is called completing the square. A lot of students have trouble with it, but it's really fun, I think. You do have to remember one of the biggest things is that if you have a squared plus 2ab plus b squared, that equals a plus b squared. So what we're trying to do is go from this one, so the written out form, to the parentheses. All right, that's our whole mode. So in this first example, what we're going to do is we're going to move the 7 to the other side. So we're going to have x squared plus 6x plus, and I'm going to leave a blank, equals -7 plus, and I'm going to write that blank. What we need to do is we need to find what goes into this blank. Okay? Now, we know, or if we look, we can see that the a is x, and so then in the middle term we have the 2, the a is x, and then so that tells us that b has to be the 3. So this has to be b, right? So if we have 6x, then we have 2x, and b has to be 3. So that tells us that what we're going to add is 9, because 3 squared equals 9. Okay? So if we add 9 to one side, we have to add 9 to the other. There is another way, which is how we're going to approach the rest of the problems. Right. Now that we know that we have this 2 here, how do we get from here to here? Is we're going to take 1/2 times the 6, and we're going to square it. And that 1/2 comes from this 2 that we have in the a squared plus 2ab plus b squared. And if we take 1/2 times 6 and square it, that gets us 3 squared, which is 9. All right, now let's go back and let's simplify. So now we have x plus 3 squared equals, and -7 plus 9 is 2. We take the root of both sides, so we get, now we're going to go back to an extracting roots question. So we get x plus 3 equals plus or minus the square root of 2. So x equals -3 plus or minus the square root of 2. Now for checking our answer, what I'm going to do is I'm going to show how to check one of the answers, not both. Just because, for the sake of time. And I will leave the other side, the other answer for you to check. So I'm going to check the one with x equals -3 minus the square root of 2. And we're going to put that back into our original. So -3 minus the square root of 2 squared plus 6 times -3 plus the square root of 2. I wrote that wrong, didn't I? Minus the square root of 2 plus 7 has to equal 0. If we multiply this out, or we can go back and use the a plus b squared equals a squared plus 2ab plus b squared, then what we get is we get 9 plus, and I'm going to just put the numbers in, -3 minus the square root of 2 plus negative square root of 2 squared minus 18 minus 6 square root of 2 plus 7 equals 0. So this gets us 9. These two make plus 6 square root of 2 plus 2 minus 18 minus 6 square root of 2 plus 7 equals 0. So then the 6 square roots of 2 cancel, and I have 9 plus 2 plus 7 is 18, and 18, so I get 0 equals 0. And I will leave you the other solution, so you get to check x equals negative 3 plus the square root of 2 for yourself. Okay, let's go on and do the next example. This one, the negative 5 is already moved over to the other side. So that's good, but we have this leading coefficient that we need to pull out. So we're going to first pull out the 2, so we have x squared plus 3x plus parentheses equals negative 5 plus blank. All right. So now we're going to do what is half of 3 squared. And that's what we're going to add right here. So we want half of 3 squared. Well, that's going to be 3/2 squared, which is going to be 9/4. Now, I'm going to ask a question. Did we actually add 9/4? I have not had enough caffeine this morning. And it's morning for me. Maybe night for you, but it's morning for me. So, no, we did not actually add 9/4. We actually added 2 times 9/4, which is 9/2. So what we're going to add over here is going to be 9/2. All right? So this, on the left side, we get 2 times x plus 3/2 squared. And we'll always know that when we complete the square, that this little value right here is what goes right there. And over here, we're going to get negative 10/2 plus 9/2. And so this side equals negative 1/2. All right? So then we divide both sides by 2. And this actually is 2/1. So this becomes x plus 3/2 squared equals negative 1/4. All right, I'm going to scroll up just a little bit. So now using extracting roots, we get x plus 3/2 equals plus or minus the square root of negative 1/4. So x equals negative 3/2 plus or minus I over 2. Or you could write that as negative 3/2 plus or minus negative 1/2 I. Both are the same. I am going to actually write it as this, negative 3 plus or minus I all over one denominator. All three of those are 3 ways to write that same solution. Again, I'm going to only check one of them just to save time, and I'm going to leave you the second one. Okay, so I'm going to check negative 3 minus I over 2. And I'm going to put that back into the original. So that's 2 times negative 3 minus I over 2 squared plus 6 times negative 3 minus I over 2 equals negative 5. All right? So now I'm going to do, it's legal, but I'm going to square the denominator before I multiply out the numerator. So I have 2 negative 3 minus I squared over 4 plus, and this 6 cancels with this and leaves a 3. And so I have 3 times negative 3 minus I equals negative 5. Now, I'm going to go right over here, and I'm going to say negative 3 minus I squared. So I'm going to do this arithmetic, or this math, over to the side. It's not really arithmetic, but algebra. So that's minus 3I minus 3. And I'm going to just multiply all this out over to the side so that I'm not having to write this whole long thing so many times. And I don't know if you can hear him, but my puppy is outside and he wants to come inside and nobody will bring him in. So what I've done is I've distributed the first parentheses into the second. Now I've distributed the negative 3 and I into the second, and so I have 9 plus 6I plus I squared. So this is 2 times 9 plus, oh, no, it's not, 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 no, it's not. Okay, the 2 cancels here. So it is 1/2 times 9 plus 6. No, it's not, no, it's not, 6I, and I squared is minus 1. Because remember, I squared equals the square root of negative 1 times the square root of negative 1, which equals negative 1, so this is actually 8 plus 6I. All right. Ha ha ha. Now we're going to go back over here. So we have here, we have the 2 cancels with the 4, and we're left with 1/2 times minus 3 minus I squared over 2 plus 3 times minus 3 minus I equals negative 5. So now if I change this numerator, so this is 1/2 times 8 plus 6I. Boy, I love that undo key. So 1/2 8 plus 6I minus 9 minus 3I equals negative 5. All right. Then I get 4 plus 3I minus 9 minus 3I equals negative 5. So these go away, and this becomes negative 5 equals negative 5. Through a lot of mistakes, we seem to get there. All right. Now, let's go on to how to solve this one. And notice we have no numbers. What this one actually is this is actually how to come up with the quadratic formula. And I wasn't going to do it, and then I decided, you know what, I am going to go through the steps and show you how to do it. So here we go. Let's just jump in with both feet. So first we're going to pull the c to the other side, and in that same step I'm going to factor out the a. So I have a parentheses x squared plus b over a x plus blank, close parentheses, equals negative c plus blank. Okay, I hope that makes sense. Okay, I pulled the c to this side and I factored the a out of the parentheses. So the next question is, what do I add right here to make this a perfect square? Well, I'm going to multiply by 1/2 times the b over a, and I'm going to square it. All right? Then what I've actually added to the whole thing is a times 1/2 times b over a squared. So what goes over here is going to be a times b over 2a squared. And you really want to leave it like that. You don't want to try to, oh, well, let's simplify it out. We will multiply them out and square them, but let's give it a minute. Okay? So now I'm going to rewrite this down so that it's a little simpler. So we have a times x plus b over 2a, quantity squared, okay, equals negative c plus a, and now I'm going to square this out. So this is b squared over 4a squared. Okay, now between these two fractions, my least common denominator is 4. Oh, wait. I need to go back a step. Okay, what I need to do is I need to simplify this right here. So I have a x plus b over a, b over 2a squared equals negative c plus b squared over 4a. Now, my LCD is 4a. So I want to get this side as one fraction. Okay? Let's b over 2a squared equals minus 4ac plus b squared all over 4a. Kind of looking familiar? That's what's under the square root. Now, I'm going to divide both sides by a, which puts this a in the denominator. So what I get is x plus b over 2a quantity squared equals, and I'm going to reorder this so that it's b squared minus 4ac all over 4a squared. All right, because remember, this is fraction division. So if I have, and I'm just going to go over here, if I have x over y divided by s over by s, that's really s over 1. So that's x over y times 1 over s. Okay? Just to remember, that's just a little sidebar so that you remember how to, that's how that works. All right. Now, by extracting roots, I'm going to take the square root of both sides. So I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Well, I can take the square root of the denominator, so I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. Pull this term to the other side, so I get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. All right, now we have the quadratic formula. Now, some of you might be thinking, why is that important? Well, if you're teaching middle school math and you're teaching high school math, then this is big. You need to know how to show your students how to derive the quadratic formula. And there you go. Now, the next question, which is our last example, is how to use the quadratic formula to solve. And so let's go forth. Again, you have to set, it's a quadratic, so you need to set it equal to 0. All right, so let's go. So we're going to have 2x squared minus 2x, pardon me, equals 3x plus 1. Pull these to this side. So 2x squared minus 5x minus 1 equals 0. So the quadratic formula states, in words, if I have ax squared plus bx plus c equals 0, then I know x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's very important to know all the conditions when you use something. It's not just this, but it's if I have this quantity equal to 0, then I know this. So a equals 2, b equals negative 5, and c equals negative 1. Okay, so x equals negative 5 minus the square root of negative 5 squared minus 4 times 2 times negative 1 all over 2 times negative 1. Oh, 2 times 2. So this is 5 plus or minus the square root of 25 plus 8 over 4. So that's 5 plus or minus the square root of 33 over 4. All right, so now we're going to check. Now I'm going to check one of these. Now it says using Wolfram Alpha. So I'm actually going to do it this way because I'm on an iPad and I can do this provided I can find the apps. Safari will work. Let's go here. Wolfram Alpha. And what you're going to type, this is the first time we've used this, is you want to evaluate two x parentheses, can't type, parentheses, x minus 1 parentheses equals 3x plus 1 at x equals, and then you put in what you want to evaluate it at. And we want to evaluate it at 5 minus, and here's how you do square root, SQRT, parentheses, 33, close parentheses, close the numerator, divided by 4. And you hit go. And it says no solution exists. Okay, let's try this. There's another way around this. Solve. Go.